Okay, so we're going to go over this problem, and we just grabbed this answer from our previous activity from 5.9. So now we're going to go from we're going to take the very first number and rewrite it into polar form. So the first thing that I do is I draw it here, and then I graph it. Let's use this. So -1 plus 1, -1 plus 1 looks like this. I'm going to make it bigger just so I can make it bigger. So that's a -1 plus 1. And then I draw a line. So, right, you draw the thing, you draw the angle, and then you draw your triangle. Does anybody recognize this triangle? Does anybody recognize this triangle? Does anybody recognize this triangle? Yeah, this is a 45, 45, 90 triangle. Very good. Ms. Johnson, how did you know that this was a 45, 45, 90 triangle? How would you tell that this is a 45, 45, 90 triangle? Yeah, the ones. And plus, once you graph it, you're like, oh, this is a 45 because these two sides are congruent, right? So once you figure out that it's a 45, 45, 90 triangle, now you know this is a pi over 4 if you're talking in radians, which at this point, I think you should be comfortable with that. So that's pi over 4. So now you want to know this angle here, which is from here to here. And some of you have really taken on this idea of like slices of pizza. So here, this is a whole pie or a whole pizza, which is cut into 4 slices. So that's 4 pi over 4, right? And I took away a slice. So how much is this angle here? How much is this angle here? Yeah. No, that's 45. But this here, it's 3 pi over 4, right? So do your best to talk in terms of pi, because the sooner you do it, the easier it becomes. Okay, so that's 3 pi over 4. There goes your theta. And what's the other thing that we need for polar besides our theta? What's the other thing that we need? We do not need beta. So polar is always going to be something comma theta. What is this guy? What's this guy that we need? Who's missing right here? Yeah, it's our r. And our r is our hypotenuse, right? Of our right triangle. So if you know your 45, 45, 90 triangle, it's 1, 1. What's this side? Yeah, square root of 2. Very good. And for those of you who don't know your 45, 45, 90 triangle, look how much simpler this becomes because you know your 45, 45, 90. I recognize that it was a 45, 45, 90 because of the 1, 1. I knew this was pi over 4 because it's a 45, 45, 90. If I take one of them out, then there's 3 pi's over 4, so that gave me that. Because I knew the radius is the hypotenuse, and I know 1, 1 root 2. So all of this depends on my knowledge of knowing the 45, 45, 90. So then my polar coordinate here is going to be r, which is the square root of 2, comma theta, which is 3 pi over 4. And so there is your first number. Okay. Can you check doing your second number? Go ahead and check the second number. Okay, for the second one, you're going to do the same exact thing. You should already recognize that it is part of the 45, 45, 90 because there's a bunch of ones everywhere. And so I'm just going to draw it on the same one, except for I'll go like with a different color. So it'll be -1, left 1, and then down 1. So it's right here. So you have the reflected triangle down. Does everybody see that? So still 45 degrees, still square root of 2 as the radius. So I can already write that down. The only thing I need to figure out is my my angle. So this is still square root of 2. Everybody's okay with my square root of 2? Questions on my square root of 2? Okay. And then you have to figure out the angle. So now, how would you figure out this angle? How would you figure out this angle in here? What's the math behind that? That's exactly it. Good job. Okay, no doubts about you not knowing it, right? What about the rest of you? What about how big is this angle? So again, this is 4 pi over 4, but instead of subtracting a slice of pi, I add it. Very good. Now, this, for those of you who are talking to me in degrees, try it in. The only way you're going to get better is if you talk to me in pies. So let me say this again. For this one here, I'm going to go here, which is 4 pi over 4, and then I'm going to add one more slice. So yeah, that's 5 pi over 4. So very good. 5 pi over 4. Good. So then that's 5 pi over 4. Okay. And that's it. So you should be, this part here should be really comfortable. Okay, very comfortable. Now, so now I'm going to layer on this new part, right? So now I'm going to layer on this new part. So when you're laying around the new part, this is how you multiply. So here, this is how to multiply complex numbers in polar form. So we've been doing it like this, where we convert it to Cartesian and then we convert it to polar, right? And so now I want to make sure that you guys are all comfortable with that. Okay, so here goes. What you're going to do, oh man. So what you're going to do first is multiply your radii. Some books call this your magnitude. Later on, you will call this magnitude because you're dealing with like vectors. Magnitude just means the length of that arrow. So a vector is like, imagine that I made this an arrow. Okay. So multiply your radii. So go ahead and do that here. What's root 2 times root 2? What's the square root of 2 times the square root of 2? What's that? Very good. It's just 2. Not a big deal. Ms. Johnson, I got this. I'm okay. Okay, so that goes in your first one here. So put that as your radius. You guys are fine with that. Let me put that in as my radius. 2, comma. Okay, and then your second set of directions, I'll put it in a different color maybe, is going to be add your angles, which seems weird, but it makes sense if you think about properties that you may have not used before. So here, adding your angles looks like this, right? 3 pi over 4 plus 5 pi over 4 is who? Who's 3 pi over 4 plus 5 pi over 4? I'm just going to add the numerators, right? So 8 pi over 4, thank you. And then you simplify, which is just 2 pi. Okay. So here I put 2 pi. You could have also put, what's 2 pi's other name? Anybody remember? Where's 2 pi on here? Where is 2 pi on here? Oh no, 2 pi. That's 1 pi. this is 1 pi here. We want to go 2 pi, right? It's 360. So this guy's name is 2 pi, but his name is also 0. It's like me. You guys call me Mrs. Johnson. My children call me Mom. I'm the same person. I'm the same angle, but I have 2 different names. Sometimes even more than that name, right? So if you look back at our previous, where is it? He's over here. This one. Right. If you look back at our previous one, sorry, I need to anonymize. You got, some people wrote this as 0. See how they wrote it as 0? 0 and 2 pi are the same thing, right? 0 and 2 pi are the same thing. Okay. And then you would write it polar trig, same thing. You're doing the same thing. So this is going to be 2, sorry, it'd be 2 cosine 2 pi plus I sine 2 pi. If you remember this, sine of 2 pi is going to be 0. And then, so that's going to be 0 i's. Cosine of 2 pi is 1 because it's asking for the x coordinate. So this is the same as this, which is just 2. So the only new thing that we went over here is this right here, how to multiply. So here I have my polar coordinates. It says to multiply your radii. So that's root 2 times root 2, which is just 2. And then add these together. Boom. And this is based on an identity that you don't need to know about right now. Just know that this is how you multiply polar numbers. And so what you just verified is it doesn't matter if you, let me get this right. It doesn't matter if you multiply first and then convert to polar and trig, or if you convert to polar first and then you multiply, you'll still get the same answer. Some of you are still bothered by the fact that this says 0 and it's right, and this says 2 pi and it's right. It's really because 0 and 2 pi are the same thing. It's like a $20 bill and 2 $10 bills, right? They have the same value. It just looks different, right? So back to over here, which part of this is going to mess you up on the test? What part of this is going to mess you up on the test? So if you can figure out what part of this is going to mess you up on the test, then I need you to practice that part. I think people are comfortable enough to get into polar, and if you're not, practice that. That's 5.7, 8. No, 5.8 and 9, and now 10. So we've been doing converting for quite some time. Converting from polar to trig, I think everybody's comfortable with. Converting from trig to polar, everybody's fine with. It's really from going from Cartesian to polar and polar to Cartesian where you guys are having some issues. Okay, so now I would like you to practice. Go ahead and practice this one and see. Let's see if you guys can get the same kind of work.